Good morning, Green Girls. So we are on 8-7 today, and you are learning about the Pythagorean theorem. Woo! Mr. Pythagoras, who was a Greek. Did anybody have him for the Wax Museum? I forget. But Pythagoras, this is something that he was able to come up with a long time ago. And I think he was alive before Jesus was born. It's been a long time, and it's still relevant and still used today. So there, we're looking at the concept of a triangle here, and how they don't do base and height anymore. They're talking about a leg and a leg, meaning like your X and your Y axis maybe, and not all triangles are like that. And then the diagonal line would be then called the hypotenuse. Hypotenuse is how you pronounce that. Sorry, we're on page 405. And so you have some yellow words that you can put in your measurement and geometry book. They talk about when you understand the Pythagorean theorem, you use right triangles to find unknown distances. In a right triangle, the shortest sides are legs, the opposite diagonal is the hypotenuse. His theory states that in any right triangle, so it cannot be scalene or acute, obtuse or acute. It has to be a right triangle. The sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. And he came up with this formula. A squared plus B squared equals C squared. A is being a leg, B is being a leg, and C is the hypotenuse. And when each of those is squared, they will equal each other. How about that? And again, the legs are added. So they give you this baseball diamond over here, and they tell you that from base to base, it's 90 feet, okay? So his theorem is A squared plus B squared plus C squared. They did it backwards, just so that you could figure out C, the variable. And so if we used, let's just go ahead and use, let's use the right side of the triangle. If you use home plate to first base as one leg, first base to second base as two legs, so you're going to square 90, which we'll let the book do the math, is 8,100. When you add those two, that's going to be C squared. Now to just find what C is, you have to take the square root of 16,200 to do that. You can't divide it by 2 because it's not doubled. It's about being squared. So that's why they had to teach you about square roots in order to do that. They give you this quick check here. So 8 is a leg, 15 is a leg. We have to find the value of C. In order to do that, we follow Pythagoras' theorem. So I square 8 and I square 15. I add them together, and then I have to find the square root of that answer. Okay, so as you can see, it's 17. As you go on to the next page, if they were to give you the hypotenuse and a leg, and you have to find the other leg, you are going to work through this equation in a different way. It's just like before with algebra, you just solve to find the unknown. So without even looking at the figure over there, if one leg is 8 and the hypotenuse is 10, they plugged it in. So 8 squared is 64, 10 squared is 100. I can't just add these two. I'm going to subtract 64 from each side because that's what we do with algebra. We have to get the variable by itself. And so what we do to one side of the equal sign, we do to the other. 100 minus 64 is 36. To find the value of a leg, not the leg squared, but if I then go and find the square root of 36, which is 6, back over here, A is going to represent 6 meters. Leg, hypotenuse, we had to figure out the other leg. So that's how that is done. You are going to do the You Try tonight on page 407. I want you to do number 6 through 15. Again, a way for me to check that you understood this. It's very much a mathy lesson. If you have a calculator, you may use it to find very large square roots. Like when we were doing on that, sorry, I'm flipping again. When we were doing that 16,200. Because you would just be guessing, and that's going to be a big number, and it's not equal. So you may do something like this on a calculator, 16,200, and there's a little square root button, and when you press that, it would then tell you 127.3. So you may do that on a calculator. That is okay. Again, it's knowing how to use his formula, his theorem, versus having to do the math in your head. So when you get to that point, something like this you can do on the calculator. Okay? So, can't wait to see how your answers go, and hopefully you understood. Any questions, you can go ahead and email me.